2.6 is double replacement reactions. And these are always going to include two ionic compounds. And so first we're going to translate each of our ionic compounds, and then we'll predict the products. So my first compound is aluminum nitrate. Aluminum is +3, nitrate is -1, they switch, and sulfuric acid, which is H2SO4. Lead 2 nitrate is Pb +2, and nitrate is NO3 -1. Switch the charges to get PbNO3 2. Potassium sulfide is K+1, S -2, switch the charges. Calcium acetate is +2 -1, switch. And iron 2 hydroxide is +2 -1, switch as well. And my last one, ammonium oxide, is +1 -2, switch. And copper 1 sulfate, which is +1 -2, switch. Now that I have all my compounds translated, let's talk about how to predict the products for a double replacement. First of all, we're always going to switch the cations in a double replacement. The cations always come first. So aluminum is going to switch with hydrogen. These are always the cations, the ones that are in front of the compound. Aluminum and hydrogen will switch spots. They should remain in the front because they are cations as well. We never carry numbers forward unless they belong to the polyatomic ion. So I'm going to bring NO3 over, but I will not bring the 3 forward. I will bring the SO4 forward, but the 2 will not go forward. And so we'll see this as we work out each of these problems. So let's start with the first one, aluminum nitrate and sulfuric acid. And I want to switch the aluminum and the hydrogen. So my new compound is going to be hydrogen and nitrate, and my second compound will be aluminum and sulfate. I have not carried numbers forward except for my 3 that belongs to nitrate and my 4 that belongs to sulfate. Now I need to cancel or switch the charges. Hydrogen is +1, nitrate is -1. They cancel, so now I'll erase them. Aluminum is a +3, sulfate is a -2, those switch, giving me Al2, and SO4 goes in parentheses with a 3. And now I can erase these charges. This is my final answer. Remember, you're supposed to balance the equation, however, we're not going to worry about doing that at this time. The second one, my cations are lead and potassium. So I'm going to switch lead and potassium. We're going to have potassium with nitrate, and we're going to have lead with sulfide. Realize that it is lead 2. This 2 lets you know that the lead has a +2 charge. That is the case on the right-hand side of the equation as well. Lead is a +2. So here again, this 2 lets you know that this is lead +2. Therefore, this is also lead +2. So now let me balance my charges. Potassium is +1, nitrate is -1, they cancel. Lead is +2, sulfide is -2, those also cancel, so this is my final answer. Potassium nitrate and lead 2 sulfide are my products for this reaction. The third one that I'm going to work on is calcium acetate and iron 2 hydroxide. We're going to switch the calcium and the iron. So I'll have iron, which is a +2, I know this because of this 2 right here, and acetate, plus calcium and hydroxide. Okay, now I want to balance my charges. Acetate is a -1, so I'll switch the charges, and I get a 2 here. And then calcium is +2, hydroxide is -1, and I'll switch the charges again. Erase my charges, and here's my final answer. The last example is ammonium oxide and copper 1 sulfate. Ammonium is my cation, which is going to switch with the copper. And this, you need to remember, is copper +1. So ammonium is now going to have copper in its place, and it's copper 1, and that's with oxide, plus, and then ammonium is going to take the place of the copper, which will join with sulfate. Okay, I'm going to balance my charges. Oxide is a -2, so I'm going to switch those charges. Ammonium is +1, sulfate is -2, so I'll switch those charges as well. And then I'll erase the charges because I don't need them once I have canceled or switched with them. And this will be my final answer for number 4.